Construction skill 21 is about solving a problem involving measurements. And I suspect that we might want to look at this box first. Actually, no, I think we better read the question first because I don't even know who Nate is. To make shelves for a bookcase, Nate needs 7 pieces of lumber, each 45 inches long. Nate has several 10-foot lengths of lumber in the width and thickness he needs. How many of these 10-foot boards will Nate use? And the answer is number 1. He will need 4 of them. So now let's take a look at what we're talking about here. They tell us, and I agree with this 100%, to imagine Nate's finished bookcase. A picture is worth 1,000 words. To me, it's worth 10,000 words. I do better with pictures. So sketch yourself a bookcase. We know that he's going to have shelves. He needs 7 of them. And that's what we see here. We see the bottom and the top and then the shelves in between. And then we see those side pieces. Imagine comparing cut pieces with an uncut board. So we know that he has some boards that are 10 feet long. We could get 2 of the 45-inch shelves out of there, but not 3. So if you imagine all 7 of the shelves, you would need 3 boards to cut 2 pieces, and then you would have to cut the 7th piece from a 4th board. So that is one way to solve this problem. You can draw it out. But I suspect they're going to go with math. So let's look at their solution. Nate will cut each 10-foot board into as many shelves as possible. Notice that the length of each shelf is given in inches and the length of each board is in feet. The first step is to change all lengths to the same unit, feet. You could also change all units to inches. And I can tell you right now that I would go to inches. I always go to the smaller unit and then convert from there because I hate fractions. Step 2 is to find the number of shelves that can be cut from each 10-foot board. We know that we can get 2 out of each of the boards, but 3 would be more than 10 feet. So Nate can only cut 2 shelves per board. Then ask yourself, cutting 2 shelves per board, how many boards will Nate need for all 7 shelves? 1 board is needed for 1 or 2 shelves, 2 boards for 3 or 4, 3 boards for 5 or 6, and 4 boards for 7 or 8. He doesn't need 8 shelves, but 3 boards is not enough. The calculator may help with part of the calculation, but the solution lies in understanding the problem. So I want to show you how I personally would work this one. You do not have to do it this way. This is just the way I would do it. All right, so the first thing I'm going to do in my problem is highlight the important stuff. I know that he needs 7 pieces that are 45 inches long. So those 2 pieces go together. I know that he has at most a 10-foot board. Okay. And that's all I need to know. One thing, though, that is incredibly important here. You have inches and feet, and we are not setting up a proportion. We're actually solving this problem. So I have to convert everything to feet or everything to inches. And I always, if I'm doing this for myself, I go to the smaller unit, and that's inches. So the 45 is already inches. I need to convert 10 feet down into inches. Now, if you can do that in your head, that's great. That would be 120. Here's how you do it. I know that 1 foot is 12 inches. And I know that the board is 10 feet long. So I will be doing 12 times 10, which is 120, divided by 1 is still 120. So the 10 feet are equal to 120 inches. All right. And then I would use a proportion. I would compare boards. Is that what I want to do? Let me not use the word board because that gets a little confusing. I would compare pieces. We know we need 7 pieces. And I'm going to compare that to inches. All right. So 1 piece is 45 inches. He needs 7 pieces. And actually this will work, but this is not what I want to do. Let me think about this a second. How would I explain it? I still would use the drawing. I think that is the best way. So let's look at a board that we have just figured out is 10 feet or 120 inches. And then I would start cutting that board up. So I know that I have 45 here. Here's another one. That's 90. And then this little piece would only be 30. Okay. We're not going to use that little piece. It's not big enough. We need at least a 45-inch piece. So there's 1 piece. Here's 2. So he can get 2 shelves from 1 board. There would be some extra that gets cut off and thrown away. So he would need 4 shelves, he would get 4 shelves from 2 boards. He would get 6 shelves from 3 boards. And the 7th shelf would come from the 4th board with a lot left over. Okay. That's how I would approach this problem. Doesn't matter, you can do it either way. You could take the 10 feet, leave it as 10 feet. Section up that board. So there's 3.5 feet. There's another 3.5 feet. That's 7. And then you would have what am I talking about? 3.5. 45 inches. I'm getting myself confused. I'm sorry. 45 divided by 12 is 3.75 inches. You see why I go to the inches. I don't go to feet. This bugs me. There we go. So that would be 6, 7.5. And then you would have, 2.5 feet right here. Either way, you can work with it in feet or in inches. You are doing the same concept. You're doing the same process. And I'm sorry that I got us off track. Let's look at these practice problems and hopefully I can do better. Here's one of those concept questions. A compact disc, that tells you how old this book is, plays 75 minutes of music. Which expression can be used to find the maximum number of songs in that can be recorded on one CD if the average length of a recorded song is 2 minutes, 20 seconds? So I'm going to start with a little bit of focus to get myself focused. The disc will hold 45 minutes, 75 minutes of music. Average song is 2 minutes, 20 seconds. So the first thing I'm going to deal with is that 20 seconds. I need to get that into a fraction of a minute. So 20 seconds. You can do this. Just think it through. How many seconds are in 1 minute? 60. Okay. Take the zeros, cancel the zeros. Then 2 into 2 is 1. 2 into 6 is 3. So 20 seconds is 1/3 of a minute. So we're talking about 2 1/3 minutes right here. So that helps me eliminate some of these answers. I could get rid of 1, 2, and 3. So the question is, am I dividing the 75 minutes up or am I multiplying it? So let's think about a CD. And a CD is divided into tracks. And I'm not doing this the way it really looks, but this will help us. So if I take this CD and I section up tracks, so there's a song, that's 2 1/3 minutes. And then here's another track for another song, that's another 2 1/3 minutes. What am I doing to that CD? I'm dividing it up. Number 4 says that you would have this. You would have 1 CD, 2 CDs, and 1/3 of another CD. Okay. That's what number 4 is saying. That is not what we're doing. We want number 5. We are dividing that CD up into 2 1/3 minute tracks. Number 2. For a craft sale, Jessica is making necklaces out of silver chain. She uses 60 centimeters of chain for each necklace. How many necklaces can Jessica make if she has a total of 8 meters of silver chain? So we have 60 centimeters per necklace, and then we have 8 meters of silver chain. Got to be careful there because those units do not match. We need to know how many centimeters are in 8 meters. If you know to multiply by 100, go ahead and do that. That's fine. If you do not know, here's what you could do. I know that 1 meter has 100 centimeters, and I want to convert 8 meters. So there's 8 times 100 is 800 divided by 1. There are 800 centimeters in 8 meters. And then I need to turn around and divide 800 by 60 because each of these necklaces needs 60 centimeters. And unfortunately, I cannot use the calculator on this one. So 2, bring down a 0. 60 into 200 is going to go 3 times. That's 180. And I get 2 again. 20 again. That's going to continue, but we have what we need. She could make 13 necklaces with some chain left over. Number 3, to repair a roof, Erin uses packages of roof shingles that each cover an area of 80 square feet. If the area Erin has to cover is 3,140 square feet, how many packages will he need to purchase? Mark your answer in the circles in the grid. So let's see what we've got here. Each package is good for 80 square feet. And he needs to cover 3,140 square feet. Now, it's important that these units match, and they do. So we're good to go on this one. So I know that one package of shingles covers 80 square feet, and he needs to cover 3,140 square feet. So we will multiply and then divide by 80. And we can use our calculators on this one, thankfully. That is 39.25 packages. Now be very careful here. Will 39 packages be enough? No. He will have to buy 40 packages to have enough. This happened to me today. I'm renovating my house and I had to buy a box of flooring for one piece. I paid over $100 for a box of flooring and I need one piece out of it. But I had to have the whole box to get that piece. So be very careful with these kinds of answers. 39 is not enough. He can't buy 0.25 packages. So to answer this one, you would have to round it up to 40. Have to really, really think about those remainders. All right, applications. Heather is wrapping 10 gifts. For each gift, she needs a single sheet of wrapping paper 26 inches long. So each gift, let me get a pen instead of my laser pointer. Each gift, 26 inches. If gift wrap comes in rolls 7 feet, be careful. That is not inches, that's 7 feet long. How many rolls of paper must Heather buy? So the other piece of information that is vitally important here is 10 gifts. So we have lots of steps. The first thing I'm going to do is figure out how much she needs. She wants to do 10 gifts that are each 26 inches long. So 10 times 26, that's 260 inches of paper that she needs. The next thing I would do is figure out that a roll has 7 feet and there are 12 inches in a foot. So each roll has 12 times 7, 84 inches per roll. Now, if you know to divide here, go ahead and do that. If you don't, you can use a proportion. You can set up a proportion of, what would it be? Let's do inches to rolls, because that's what we're comparing. So we have 84 inches in one roll, and she needs 260 inches. So you have 260 divided by 84. And we can use the calculator. That is 3.09 and some change. So ask yourself again, are 3 rolls enough? No. She would need 4 rolls with a lot left over. I've seen lots of students get to that answer and then choose number 1. If you choose number 1, one of her gifts is going to be half wrapped. So be careful with those answers. Let me say 4 rolls needed, because that does not round to 4. But in this particular story, she would need 4 rolls. Alicia's phone plan includes 10 hours of long-distance calls each month. For each minute more than 10 hours, Alicia must pay an extra 8 cents. Last month, Alicia talked for 2¼ hours more than her allowed 10 hours. How much extra will Alicia be charged? So we know that she talked 2¼ hours over her plan, and that each of those extra minutes cost an extra 8 cents. Now be careful. You have mixed units here. You have minutes and hours. And I go to the smaller unit. That's just a habit I've had for a lifetime. The 10 hours here really is irrelevant. It just helps me to understand the story, but it does not factor into the math at all. So the first thing I'm going to do is convert the 2¼ hours into minutes. Now, several ways you could do that. You could multiply 2¼ times 12. You could do 2.25 times 12. But I'm going to show you another way that some students find very useful. I know that 1 hour is 60 minutes. 2 hours would be 120 minutes. And what's 1/4 of an hour? Think of the clock. If you divide it into fourths, what would it be? 15 minutes. So I'm going to take those two, the 2 hours and the 15 minutes, to get 135 minutes. And then I'm going to set up dollars to minutes. It costs her 8 cents for every minute she went over, and she went over 135 minutes. So we're going to multiply 135 times 8 cents, and I am going to not use my calculator. Sorry. I had it ready. but they will not allow that. So this is on the GED. They would not allow it. So 24, 28, 8 plus 2 is 10, and we have 2 scoops, $10.80 over her bill. And finally, Jared drinks 8 fluid ounces of orange juice every day. On his diet, Jared allows himself only 1,500 calories each day. If 1 quart of orange juice has 420 calories, what percent of Jared's daily calorie intake comes from orange juice? And they are nice to me. They tell me that 1 quart is 32 fluid ounces. So we know that he drinks 8 fluid ounces of orange juice. And we also are told that he's allowed 1,500 calories each day. So all of these are important pieces of information. I'm going to start with the calories in that 8 fluid ounces. So I'm going to set up a proportion here of fluid ounces. And I'm going to try to color code it for you so it's a little easier to follow. So fluid ounces to calories. Okay, so they tell me that a quart is 32 fluid ounces, and they tell me that a quart has 420 calories. And then they also tell me that he drinks 8 fluid ounces a day. So let's figure out what that calorie amount is for those 8 ounces. So we have 8 times 420, and we can use the calculator. That's 3360 divided by 32. And that is 105 calories in that 8 ounces. Okay, that's step 1. And then you can do a percentage. 105 out of 1,500. Let's get a decimal. Is 0.07. And of course they didn't do it as a percentage, but you can do it a couple of ways here. You know that that's 7/100ths. So I'm locking number 1. The other thing you can do is use your calculator, the ABC key, to reduce this. So you would type all clear, 105 ABC 1,500 equals, and that is 7/100ths. So either way, you can get to the answer of number 1. I like that question. That is testing so many different skills and your knowledge of measurement.